Okay, so we're going to look at series real quick. And so all that work that you've done for learning sequences, we're going to apply it here with the series. The difference between a sequence and a series is that a series is the sum of terms in a sequence. And we know that sum means adding. So we're going to add up all of the terms in a sequence. So if we had a sequence and it was 2 and then 4 and then 6 and then 8, we would just take the 2, add the 4, add the 6, add the 8, and get a total sum for this sequence. So our series notation would look like 2 plus 4 plus 6 plus 8, and then we'd use that ending curly bracket. And it would be the same if I give you another example. If my sequence was 4, 8, 12, 16, we know that we're adding 4 each time. It's arithmetic. And if it were a series, I'd have 4 plus 8 plus 12 plus 16. And then we could also have fractions, 1/3, 1/6, 1/12, 1/24, and we could have it as an infinite sequence, which has the dot, dot, dot. And when we write it as a series, we just add a plus in between, even at the dot, dot, dot. So we know we're adding all of the terms after it as well. There is a thing called a partial sum where we are only taking the sum of a certain number of terms in the sequence. So the sum of a specified number of terms. That notation, we use a capital letter S with a subscript of n. And in this first one, it says find the partial sum for each given sequence. So we're going to find the sum of the first 7 terms in the sequence. So we have to figure out the pattern first. We have to make sure we have all 7 terms, and then we'll add them all up. So we know in this one, we would be adding by 4. And so I only have 1, 2, 3, 4, 5 terms so far, but it's pretty easy to figure out the 6th one and the 7th one. And then all we would do on our handy dandy calculator is add up all of those terms. So we'd say 2, I don't think you'll be able to see that. And I don't remember how to decrease the brightness. So we would have 2 plus 6 plus 10 plus 14 plus 18 plus 22 plus 26. And that's how we get S sub 7 equals 98. We would do the same thing with number 2. We would do the same thing with number 3. We would do the same thing with number 4, and so on. So starting at 5, it gives us a rule, and we would have to figure out the terms for that rule. So I think for the most part, we know that for the first term in line, we would plug in a 1, and then we'd plug in a 2, and then we'd plug in a 3. So we could go ahead and do that. I'm going to hop down to this one down here because it's the most challenging one. I'll have the rest posted on Google Classroom, but I think you guys can probably do that without me. But we'll do a sub 1. We'll plug in a 1 for this n value. So we'd have 1 squared times the square root of 5. So the first term in the sequence is square root of 5. Then we'd plug in 2. 2 squared is 4, so the second term in the sequence is 4 root 5. Third term is 9 root 5. Fourth term is 16 root 5, and we're going to go all the way to the 6th term. Fifth term is 25 root 5, and 6th is 36 root 5. And then because we are finding the sum of the sequence, or I'm sorry, we're going to find the sum of the series, we would just add all of those up. And since we know that they all have a radical 5, that is what makes them in common, so we would add all of those together, and then we end up with 91 root 5. We do want to leave it as a radical. We don't want that big, long, ugly decimal. So that's kind of the baseline where we're going with this. I'm going to show you how to use this summation notation, and then I'm going to show you how to plug it into Desmos, and it'll be pretty simple. So we've got this crazy thing called summation notation. It's a Greek letter. I believe that it is sigma. You might have seen it in like a Greek sorority movie or something like that, but we're going to use it for math. It just means sum. The value up here at the top is the last term number. And this n equals 1 down at the bottom is telling us where to start. So in this sequence in particular, we're going to have the first term all the way to the 5th term, and that's what we're going to add up. So that is first term number. So where we start, where we end. This 2n over here is the formula for the sequence. So we spent a couple days figuring out the formula for arithmetic sequences and then formula for geometric. And so that formula that we came up with is going to go here. Sometimes it'll be given, sometimes you have to figure it out. So for this one in particular, we're going to find the sum of the first to the fifth. And so if we did it by hand, and I'll show you how to plug it into the calculator in just a minute, we're going to plug in a 1. So 2 times 1, if n is 1, is 2. Then I'll go to 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. And that's where I stop because the top number is a 5. I'm going to add all of those up, and I get a sum or a partial sum of 30. All right, in your calculator, okay, if you're using a handheld calculator, you're going to hit the math button, and you're going to scroll all the way to the bottom, and it's going to have summation and then that Greek letter E. You can hit that, and then the calculator will actually have this sigma for you. I know you can't really see it. I'll show you on Desmos in just a second. So in this one in particular, we're going to put in our variable. We're going to use x because we don't have to finagle anything. We know that it's going to be 1. At the top, we're going to have 5. And then whatever variable we use in the sigma, we want to use it over here in the parentheses. So we'd say 2x. And then we'll calculate it, and we got 30. On Desmos, you're going to go to your keyboard down in the bottom. Nope, not the keyboard. You're going to go to functions, and then you're going to scroll to calculus. I'll leave a screenshot in Google Classroom because you can't see that either. Oh, there it is. Okay. So you're going to hit functions, and then you're going to scroll all the way to where it says calculus, and then you'll see where it has a sigma, and it'll populate the same way that it does in the calculator. And so we would type in 1. At the top, we type in 5. You have to add your own parentheses, and then you do want to make sure you're using the right variable. So if you use n below the sigma, you want to use n in your function, and that equals 30. So if you turn your notes page to the other side, there are 2, 4, 6, 8 practice questions where you can practice plugging that into the calculator. I'm not going to do that on the video, but I will have the answers posted on Classroom. That way you can make sure that you know how to plug it in correctly. So we're going to hop over here. And the only thing that we're going to add is we're going to combine what we learned about arithmetic sequences and what we've now learned about the sigma notation. So arithmetic series is just the sum of an arithmetic sequence. And I'm going to show you 2 ways to do this. One is using this partial sum formula. So S sub n equals n times a sub 1 plus a sub n over 2, where n is the number of terms. A sub 1 is the first term, and a sub n is the nth term, or the last. And so in this first one, I'm going to show you 2 ways. I'm going to show you how to do it with the partial sum, and then I'll show you how to write it for sigma notation. So first thing we're going to do is figure out the formula for it. A sub n, we're going to use the dino because that's the shortcut. We know that the difference is 3, n for the n in dino, and then 1 before the first. So if I work backwards, 16, 13, 10, 7, we'd have 4. And so that's our explicit formula. We know that the first term is 7. We know that the ending point is going to be a sub 18. We do want to go ahead and calculate that so we would know where we're ending. So we'd have 3 times 18 plus 4, and so that 18th term is 58. If we use this partial sum formula, we're going to have s sub 18. We'll have 18 for our n value. We'll have 7 plus 58 over 2. We'll calculate that, and we end up with a sum of 585. Over here off to the side, You've got this formula that you can use, but now that you have access to Desmos for all of the things that you're going to be doing, what we really just want to do is use that sigma notation. So we know we're starting at the first term, we know we're ending at the 18th term, and we do know how to write a formula for an arithmetic sequence. We already figured it out. It was 3n plus 4. You can plug that into Desmos or your calculator and get the 585 as well. As long as you can write the sequence, the explicit formula, you can use the sigma notation. So real quick, if we just use the sigma notation, we know that we're starting at the first term, we're ending at the 35th term. We know between terms we're subtracting 8, and we know 1 before the first would be 58. We can plug that into our calculator or Desmos or whatever you want to use, and we know that the sum for the 35 terms is negative 3,010. And you want to make sure that you get that. You want to make sure that you're plugging it in correctly. I will have the answers for 3, 4, 5, and 6 on Google Classroom. You can check and make sure that you are doing the right thing. Make sure that when you're plugging it into the calculator, it is using order of operations. You're smarter than the calculator. Make sure that you make that true. So couple more on the back where you can practice. The difference here is that they're starting at a different term, so it's not necessarily starting at the first term in the sequence. It's starting at the fourth or the second or the third. And the only thing you would change is plugging that into Desmos. So you don't have to do a whole lot of work there. We're going to look at 2 application problems real quick. We're actually going to skip this one about the bricks. I'm making you do all this other stuff, and this one you end up having to solve with quadratic formula and all sorts of stuff. So we're just going to skip that one for now. We might come back to it later. But number 11, it says, Michaela is training for a marathon. She ran 2.4 miles the first day, 2.55 miles the second day, 2.7 miles on the third day. If this pattern continues, find the total distance she ran after 60 days. If we were in class together, I'd tell you all about training for our half marathon. I got that for my birthday, but that's a story for another day. So if you watch this, you'll have to remind me when I come back. All right, so we know that she is making a total sum of miles for her training, so we're going to write a sequence for that. All today is using arithmetic sequences, so we know that it's going to be arithmetic. So we know the very first day she ran 2.4 miles, and then 2.55, and then 2.7, and so we know between all 3 of those days, she's increasing her mileage by 0.15 of a mile. So that's our common difference. If we use our dyno equation, we know that it's difference and then n, and then 1 before the first. So 0.5 before 2.4 would be 2.25. Now that we have the explicit formula, we'll use our sigma notation. We know that we're starting with day 1, and we want to know how many miles she will cumulatively have run after 60. Once we have that equation, guess what we're going to do? Plug it into Desmos. Plug it into Desmos. Make sure that you get 409.5 miles. And if you did, great. If you didn't, maybe try some parentheses, or make sure your variables match, or make sure you just plugged it in correctly with the 1 and the 60. The last one, tickets for a concert opened up for sale online. The number of people that purchased tickets in each of the first 4 minutes is shown in the table to the left. If this pattern continues and the concert venue can hold a maximum of 75,000 people, find the number of tickets left after the first 2 hours. So we do have a couple of units here. We have 2 hours, and then we have first 4 minutes. So just be aware of that. That could play a role. And then instead of giving it in words, it gave us this information in a table. So the first thing we want to do is figure out the difference. Again, we know it's arithmetic. That's what this day is all about. And so we see that it is increasing by 8 tickets a minute. So we know that my explicit formula, we'd have 8x or n, and we know 1 before the first would be 27. And what we're trying to figure out is from the first minute to the 2 hour mark, which would be how many minutes? 120. So we'll say 120 minutes. So it did play a role. We needed to know first minute to 120 minutes instead of 2 hours. 1 to 2 wouldn't have been very many. So we would find that sequence, plug it into Desmos, and we end up with 61,320 tickets sold. Now that answers the question how many were sold, but it doesn't answer the question find the number of tickets left after the first 2 hours. So the max capacity is 75,000. So we would take the 75,000, subtract it, and we know that there are 13,680 tickets left to be sold. Try those. I do want you to finish the practice on the other side. Most of it is a calculator workout, so just make sure that you know how to plug it in. We'll check it when I return. Thanks, guys.